friends. Welcome to the Boolean Brain in continuation to the LeetCode Daily Challenge series where we are solving the daily challenge from LeetCode end to end. Let us take a look at the today's problem statement. We are on day 10, so let us take a look. The title says minimum ASCII delete sum for two strings. Given two strings S1 and S2, return the lowest ASCII sum of deleted characters to make two strings equal. So we have given two strings and we can delete some of the characters from each of the string so that the s1 and s2 becomes equal. Let us try to take understand this example. So we have s1 is c and s2 is equals to it. So if we delete yes from c and it becomes ea, and we can see ea is common here, so we can delete t from it. So the deleted value of yes is 115 and similarly of t is 116. So the total sum is 231, so we simply return 231. Let us try to understand second example. Now s1 is delete, s2 is lwt delete. So if you carefully observe l e t, and here is also let. So friends, one thing is here we can delete the elements so that uh, the rest of the elements stay as it is and form a string. So this is, so it basically suggests us to find the subsequence. Okay, apart from that we need the lowest ASCII sum of deleted characters. So whenever we want lowest ASCII sum, what does it mean? It indicates we have to delete minimum elements. Okay, if we want to delete the minimum elements, we want the longest common subsequence, isn't it? So that's how we have to break the problem statement. So uh, this is the problem statement given to us. If we carefully read and understand this, we have to find the subsequence and we have to find the lowest ASCII sum. So that in order to obtain this, we have to delete minimum elements. If we delete less, the sum would be minimum. And if you want to delete the minimum elements, the common subsequence that we need to find, that should be the longest. Then only we should be able to get the minimum elements. So now the problem statement converts to longest common subsequence, which is a standard and easy problem that can be solved easily using recursion. And so recursion solution would not be accepted. We have to further optimize this with DP. So once the recursion solution is ready, the next step of memoization is very simple. Okay, now let us try to code this, guys. So whenever such problem statement arises, you have to think in a way so that it reduces, the problem statement reduces to a standards problem that we are aware of. Okay, now let me take a helper function. This would be my recursive. It starts from 0 0, which is the ing of s1 and s2, and also takes the s1 and s2 as the input. Okay, now let's complete the definition of this function. So this accepts two pointers int I and int j and two strings, string s1 and string s2. Okay, so what are the base conditions? The base conditions is at each point we have to make a decision. Either we have to select if both are matching, or select this and skip on the next, or skip this and pick on select the next. So we are increasing, right? So the base condition is comes to like I should be less than the size of s1 and j should be less than s2. But if it exceeds, it means we can add a check. If let me declare fetch the sizes of 2 to write the clean code int n equals to s2 dot size. Okay, if I exactly equals to m and j exactly equals to n, sorry, it should be or, if any of the values reach to m, I can simply return 0. Okay, now let us check the recursive steps. Before recursive, what when I can check select ith element and jth, when s1 of I is exactly equals to s2 of j, I can basically return the ASCII value of the current element, which is nothing but s1 of I can keep s1 or s2, anything is fine, plus I need to go to the next step by calling the recursive step. So if I'm selecting both the elements, it means in the next iteration I have to increase both, isn't it? Okay, what if what if both are not equal? In that case, I can two options. I can select the ith. If I select the ith, my helper function looks like I plus 1 and j, and if I just select the jth element, I need to increase the j pointer. Okay, now here out of this I need to return one max of, because we need maximum ASCII value. So if we so this helper function responsibility is to give us the maximum ASCII value of the common, so that we can reduce it from the answer later on. So int max ASCII equals to this. I also need um, int total ASCII initial assigned to 0, and I need to return this total ASCII minus 2 times. Why 2 times? Because this max ASCII would give me the sum of the common for once, but those are in twice in both the strings. Okay, let us compute this as well. For in I equals to 0, I less than s1 dot size I plus plus, sorry, this should be okay, s1 of I. Similarly, okay, now I have the maximum, the function, rest of the function looks complete. Let us try to yeah, I hope this should work. Let us try to test this. Again, this is not the final solution, this is the pure recursive step. We need to further optimize this. Max key, okay, this should be, sorry, it should be total sum, my bad, excuse me for that. It should be total ASCII. Okay, cool. Okay, expected is 1 to 31, 0 I less than s1 s2 ASCII total. Okay, Instead of that, let us remove this from here. This would be easier for during the DP step as well. Okay, it should be, if I'm selecting the ayat, J should increase, and selecting the jth, I should increase. However, it doesn't matter, but I is less than equals to, I'm incrementing ij. Let us fetch this by reference. If s1 of I exactly is to of I, okay, let's add a log statement to debug what this returned. So whenever you end up uh, with some incorrect answers, you have to add the logs to check. Okay, my max ASCII is returning me 313, which for this case C, it should not have been written. Okay, so if my both are same, I'm selecting one of the element and incrementing my ith and jth. If I'm selecting ith, my answer is nothing but the help, the recursive step I and j plus 1, s1 s2. If selecting jth, plus 1 s1 s2, I am returning the maximum value obtained from select I and select j. What is the issue? Let us try to run one more time. Oh, my bad. I am passing S1 twice. That's the reason it was the incorrect. Now let us try to run this. It should pass now. Yeah. Now if I submit this, it won't submit because this is pure recursive and the complexity is exponential, because at each step we are making two more recursive calls which goes to 2 power exponentially. So that's the reason we need to optimize this using the dp. Now when the recursion step is complete, converting into dp solution is very simple. What you need, we simply need to declare a 2d. And you might ask why 2d? Because my recursive function takes two variable inputs. So 2d int of m, vector of int of size n, and we will assign initially -1. I need int m equals to s1 dot int n equals to s2 dot size. Okay, now once we declare the dp, we will pass it to all the recursive calls. So these are all the places where I made the recursive calls. I added it there. I also need to receive it here. Vector of int dp. Okay, now whenever I'm returning at the end, I need to populate into dp. So this is the next step, because whatever this answer I'm returning, this is for the ith and jth state. So I simply populate it into the I and, oh sorry, I mistakenly submitted it. My bad. Let me, yeah, After the base conditions, I can also add a check. If dp of I of j not equals to -1, it means the state of I at j is already computed. So I will simply return the value present at that point. So this helps us optimize this. Now let us try to run and submit. Okay, line 4. Yeah, yeah, sample are passing. Let's submit this. Meanwhile, let us try to understand the time and the, yeah. So the solution is accepted. Let us try to understand the time and space complexity. So as you can see, we are iterating on all the elements of ith and jth. So s1 and s2. So and we are operating it at only once. So time complexity becomes O of m plus O of n. Apart from that, sorry, we are my bad. For each combination we are selecting, so it is O of m into n. Similarly, space complexity becomes O of m into n, because we are declaring a 2D vector of size m into n. Okay, now I hope this is clear. Apart from this space, we are also have a recursive stack space, which is less than O of m plus n, but you can consider it. So the recursive stack happens at max. How much combinations can go into the stack? M plus n. So when it's a linear, so this is the highest. I hope the problem statement solution approach and the code is easy to understand now. If you have any queries, please do let me know in the comments. Thank you.